Hey everybody, it's Mr. Carey here, and I'm coming to you this time with a science lesson. Actually, to be more specific, a technology lesson, and we're going to be using these guys today. These are my little Ozobots. And these are the bits. I'm primarily going to be working with the bits today. I do have my little Evos here, but there they are. They don't really work as well for this experiment. You'd have to change the code a little bit, but I can show you how to do that if you want. So today's experiment, I pulled off the Ozobot website, actually the Ozobot Education website, and it is called The Conjunctions of the Goddess of Love and God of War, specifically Mars and Venus. So today we are going to make our Ozobots act like the planets. Just two of them, Venus and Mars, and we're going to observe how they interact with each other. Specifically, by conjunction is when the two planets come into alignment. And we can use this experiment to solve a real-world problem of how often do the planets come in conjunction with each other. So we're going to use the Ozobots to illustrate that. Everything I have here today, with the exception of the Ozobots and my computer, and my phone, and the tripod and my coffee. But everything else, I just downloaded straight from the Ozobot Education website. So look for conjunctions of the Goddess of Love and God of War. All right, and without further ado, let's go ahead and get into our lesson. All right, so now as you can see, I have my instructions, and I kind of changed this a little bit. Took it from the website, and I just put it on Google Docs or Microsoft Word just to give me one sheet, front and back, so I wasn't really messing with the whole package. I have my maze, otherwise known as the orbital patterns of Mars and Venus, with the sun right there. And I drew my calibration circles. Now, if you've taken my lessons before with Ozobots, you've seen you draw the big circle, big black circle, and then you calibrate it. I drew a half circle here. Only because, right, if you look at my sensors, that only really covers half. So you only really need to calibrate that half. One of the things you don't want to do when you're calibrating, make a huge circle like that and then color it in. One, because it takes a long time to color. And two, if you put your Ozobot too close to the center, it doesn't really calibrate well. So first thing we're going to do is we're going to calibrate our Ozobots. So press it. And when we calibrate, right now it's kind of freaking out, right? It's going around. Press and hold. 1, 2, flashes white, let her go, and put them right on that circle. And look at that. That guy's happy. And then we'll try the other one too. Press and hold. 1, 2, let go. Put them right on the calibration circle. Boom, they're both happy. Awesome. Now, don't throw this away. Keep it handy. Because that's usually one of the things when the Ozobot doesn't work. What you're going to want to do is calibrate it. That's one of my step one of Ozobot troubleshooting. When in doubt, just recalibrate. Sometimes it works. Your program works, everything works great, and sometimes it just won't load. Standard tech support, right? Turn it off, turn it on again, and then I just recalibrate it. Okay, so now what you do when you get this from the website, the Ozobot Education site, they give you two codes. So the cool thing with this is you don't have to have any code. You don't have to make the code. It's already provided for you. So the first thing we're going to do is we're going to load one of the codes, Venus, on our little number 1 bot. So we go over to the Ozobot website, and fortunately for us, I already have it up. All right, so now to make it easier, right, I'll see students kind of trying to hold it right there. You can do that. It's just going to be really difficult to use. So what I like to do, if you can, either put it flat like that, or if you have one of these, you can just fold it like that. And now we are ready to calibrate. So let's go ahead and get our calibration circle here. And a glare on my, there we go, try and get away from that. Perfect. All right, so let's go ahead and we've already calibrated it, so now we just need to load the program. Fortunately, I already have the program loaded, right? So I have loaded it, but you go to the little guy up here, which says Programs, and then I just open Program, right? And there's all my programs. So once I've loaded it, it'll stay in here. If you download it and you're not sure where it goes, you just go Open from File, and then it'll find it, right? So I still have mine here: Planet Mars, Ozocode; Planet Venus, Ozocode, Ozocode file, right? So I can load that if I want. I've already loaded it. I'm not going to do that. So let's do Planet Venus first. Click on that, and then it'll ask you to open. Okay, now, as you can see, there's my code. Pretty simple code. Set top light color. It's kind of an orange or yellowish, right? That's supposed to represent the planet Venus. The next thing is wait 2 seconds. So you're going to open the code on your Ozobot. It's going to wait 2 seconds, and it's going to drive around. Set the line speed 35 millimeters per second, and then follow the line to next intersection or line end. So basically, it just says keep going at a line. I'm going to explain the 35 millimeters per second in a minute. So we already have it open. Great. We can X out of there. And then now let's get our little flashy code thing up here. Now I'm not going to calibrate it on the computer because I've already calibrated it. So I'm going to go, yep, I'm good. Remember, to calibrate, you got to turn your bit on, right? It is no good to not have your bit on to if you are going to calibrate it, or not calibrate it, load it. If it's not on, it's not going to load anything. Okay, turn it on. Now it freaks out for a little bit, but now, and I'm going to hold them here just to show you I can, right? And I'm going to load the bit. Now he's flashing green, so he's happy, right? As long as he's flashing green, you're good to go. If he flashes red, if he does any other colors, he does a little jig, then you didn't do it right. Or any number of things, okay? He's humming green, that means he's ready to go. So what I'm going to do is I'm going to put this guy over to the side. Not going to mess with him yet. I'm going to turn him off. Next one, I got to get my other Ozobot, and we're going to load the Mars program. So same thing, click the little dude on the program, open program, Planet Mars, open, and look, there's the Mars program. So the difference is, right, our line color is now red, right? So our set top light color is red because Mars is the red planet. Same thing, wait 2 seconds, and now you'll notice the line speed is 24 millimeters per second. Kind of cool. So it's going to go slower than Venus, which was 35 millimeters, and then follow the line until it ends. So let's go ahead and click our little lightning bolt, or what I like to call our little flashy thing. We just put calibration is complete. Remember, turn them on, and then I'm just going to hold them there, okay? And now I'm going to click load bit. Now I'm going to do it. Okay, so long as it's green, he's pretty happy, or she's happy. If it goes red, again, any number of reasons, and I can take you through some troubleshooting here in a second, because this does happen. Okay, now green, good, and I'm going to turn it off. I got to remember, number one is Mars, and my other one is Venus. Okay, so let's talk a little bit about some troubleshooting. And this happens a lot. What happens if it flashes red or doesn't do something? If it flashes red halfway, a couple things you can do. You can increase the brightness of your screen. Okay, it should be set at 100% anyway, but if it's not, all right, what you do is you go to this little sun right there, and you just hammer that thing until it's at 100%. That could be one thing. If it's set all the way to 100% and it's still not working, then what you can do is you can try to clean your screen. If that's still not working, one other thing could work, and this is where you go into your gears, right? Settings. Click your settings. Okay, go to flashing, and then it'll have your flashing speed, right? Usually it's set at normal, okay? Normal generally works. Fast is like, hey, if you've got a great screen and a great processor, by all means try it. normal is usually good, but if you're running into issues and it's not working, try slow. Okay, it does take a little bit longer. These programs, it takes 18 seconds. Okay, if that doesn't work, then try a different computer. It just could be the screen is too dark. It could be something on the screen. It could be any number of things. Okay, so we're done with our computer, but I'm not going to get rid of it. I'm just going to put it back here, just because, in case I need to load my program again. So here are instructions. Okay, print a copy of the maze. We did that. Load Ozobots. We did that. Calibrate them. We already calibrated. We kind of mixed up the steps. It doesn't really matter, but if you're feeling like you want to go step by step, then load it and then calibrate. Okay, we are now into the actual what we're going to do. So I'm going to move this, and I'm just going to read along what we're doing. So here's our maze. And what's cool about this maze is it's kind of a representation of the solar system. Now, disclaimer, I know that orbital paths of planets aren't truly circular. I know they're more of ellipses. It's difficult to kind of draw that, at least hand draw it. Computer, yes, we could. But all we did is we just take an average, right? 0.72 AUs, 1.52 AUs, right? We just take an average and then draw a circle. An AU is an astronomical unit. So that's a good vocabulary word, astronomical unit. It is the distance from the sun, here's my sun, to the earth. All right, there's the earth. Draw some continents in there. Yeah, it's pretty good, I know. So this is 1 AU, or if you like using miles, about 93 million miles. Again, it's an average, right? Because the orbit of Earth is actually like this, not a circle. Okay, so we just know 1 AU is the distance from the sun to the Earth, and that's how we measure things in the solar system. Okay, the other thing, right? We're going to look at orbital speeds. That was something else. Okay, Venus travels at a speed of about 35 kilometers per second. If you live in the Santa Rosa area in California, about Santa Rosa to probably San Rafael in about 1 second. That's pretty quick. Mars moves a little slower, probably Santa Rosa to Novato, which is still pretty quick. So obviously we can't do that with the Ozobot. We can't make an Ozobot go 35 kilometers per second. So what we did is we just took 35 kilometers per second and we just turned that into millimeters per second. And that is how the Ozobot moves. So we're going to go ahead and set this up. So your first step is to put the Venus Ozobot anywhere on the maze, right? So to turn the program on, you double click the power button. Double click, put them on, and then look at that. And they start going in an orbit. Okay, so now I want you to take a look at this arrow right there. That's how we're going to measure our time. So we have to use a stopwatch to measure the time it takes to go around 10 complete orbits. Why 10? Because it's just a great way to average how long it takes, because it may be going slower and faster and slower and faster. So I usually use my cell phone, but since I'm recording with it, I can't really do that. So we're going to use my stopwatch here. Okay. And we're going to go ahead and time in, as soon as it hits the .16. Okay, so 1 minute and 16. I'm going to let him drive around a little bit. So we have 1 minute and 16 seconds, okay? And what we're gonna do, we're gonna convert that just into all seconds, right? So 60 seconds in a minute, 60 plus 16 gets me 76 seconds. And while this dude's driving around, hey Venus, you go do your thing. Goddess, she'll still be there. All right, so now what we're gonna do, if I can get my tripod to work, perfect. All right, how long did it take to get around 10 times? Well, it took 76 seconds. Perfect. Now we divide this by 10 to get the time for a single orbit. 76 divided by 10. If we just do 70 divided by 10, that's 7. Divided by 10 would give us 7.6 seconds. Now, if you're not sure how to do that, by all means, use a calculator. I let the kids in my classes, especially for some of these division problems that get in decimals, if they haven't covered it yet, use a calculator. It's a good skill to use, right? Just don't get used to it. All right, we're at 7.6 seconds, meaning it takes 7.6 seconds for the Ozobot to go around one time, the Venus one. Now our next step, right? We're going to divide the number of days for a single orbit of Venus, okay? So in real life, Venus takes 225 days to go around the sun. Now we're going to divide 225 days by 7.6 seconds. And I'm going to show you why. So I'm not really going to do the math because I don't want to, I can if anyone wants to see me do the math. It will just look like this, 225 divided by 7.6, okay? I don't really feel like doing that, so I'm just gonna get out my calculator on my Chromebook. 225 divided by 7.6 gives you 29.605263115. Right, round it to the 2 decimal spots. So I have 29.605. That's going to round to 29.61 days. Okay, great. What does that all mean? What that means is we took Venus, 225 days, and we divided it by the speed of our Ozobot. Oh, there's Venus right there. Right, we took that and we said, okay, if it takes 225 days to go around the sun and it takes the Ozobot 7.6 seconds, what does that mean in Ozobot time? All right. So what that means is every time this Ozobot, every second this Ozobot goes around is 29.61 days or 30 days. So to put that in perspective, let's do this. So every time, and we're going to do this, right? And I'm just going to round to 30 just because so it's easier. But we'll find out that it gets, right, one revolution takes, here we go, 30, 60, 90, 20, 150, 180, 210. So it would be about 224 days, right? Pretty cool, right? So every second is 29 days or 30 days in Venus time in real life. Right? Pretty cool. Okay, now you can choose to leave Venus on there while we do Mars, because we're going to do the same thing with Mars. If you want to leave it on there, you can. It's not going to hurt anything. It's actually kind of cool to watch them. So here's my Mars bot. And then remember to load the program. You just double tap that dude right there. Just doot doot. All right, and we're going to do that. And, ooh, angry red. Well, he is the god of war. That makes sense. So, as you can see, it's kind of cool, right? Mars is going slower than Venus. Now, I can ask you, you're not going to be able to respond to me, but why do we think that is, right? Why is it Venus moves at 35 kilometers per second, but Mars only moves at 24 kilometers per second? Okay. Some of the answers I get, actually every class I answered or I asked, I got really good answers. The inner planets are closer to the sun. It's a longer distance to go around. We finally got to it where we put everything together. It's the closer you are to the sun, the faster the planets move. because of gravity, right? The sun is super massive. So if you get really close to the sun, it's going to whip you around in the orbit. The further away you are, you're still affected by the sun's gravity, but not as much, and so you're going to go a little slower. So let's go. We're going to do the same thing, and now I got a lot of time because Mars is really slow. So we're going to time Mars going around, and every time it hits this arrow, we're going to time it, right? So again, 10 revolutions. This is going to take a while, if you don't mind. And I should probably click the start button. All right, here we go. Now you can mark it right here. I've been using the beginning of this. It doesn't matter. You can use that if you want. So I'll probably use that. I'll try it with this time now. Ready, set, go. $180, 180 plus 15 should be 195. So we have 195 seconds. Okay, so now we're going to do the same thing, 195 seconds. So we are then, and I'm going to, you guys go over there. You guys do your thing. Yep, there they go. All right. And now we're going to go back to our worksheet. Okay, so how long did it take Mars to go around? Well, it took it 195 seconds. Now, I like to write it there just so I can keep track of it. So now we're going to divide by 10, right? We're going to divide by 10 because, because it went 10 revolutions. So 195 divided by 10 is going to be 19.5. But just because I have been known to make mistakes, 195 divided by 10, sure enough, 19.5. So that means every time it takes Mars 19.5 seconds to go once around the sun, the Ozobot sun here. Now we're going to divide the number of days for a single orbit of Mars. So in real life, Mars takes 687 days to go around the sun. Obviously, we can't do that here. It would just take too long. So we're going to divide 687 days. We're going to divide it by 19.5. Or if you're going to enter into a calculator, 687 divided by 19.5. I'm just going to do that because I'm not in a mood for long division. I will do that at some point. If you'd like me to do long division on some of these, go ahead and leave a comment below. Say, yeah, Mr. Carey, go ahead and do long division. Show everyone how bad you are at it. I will be happy to do that. So 687 divided by 19.5. That gives us an answer of 35.23. So what that means, 35.23. That means every second Mars moves, our Ozobot Mars moves, that is going to be 35 days. Pretty cool, right? So I'm not going to do it again, but if I were to count it, right, 1/1000, okay, 35 days, and then 70 days. So every second that goes, it's adding up 35 days, which is pretty cool, right? So now we're going to flip over and go to our other part of our worksheet, right? 6 and 9 are probably not exactly the same. They're not. They're off by a little bit. So what we're going to do is we're going to average our answers. So to average them, I'm going to take, I don't remember what my Venus one. So Venus was 29.61. And then Mars was 35.23. So this I will actually do on paper for you, just because, right? Averaging, right? So let's write a good one here. So I'm going to average 29.61 plus 35.23. So we just add them up. 1 plus 3 is 4. 6 plus 2 is 8. Bring my decimal point down. 9 plus 5 is 14. And then I have to regroup, put my 1 up here. Now 1 plus 2 is 3. 3 plus 3 is 6. So then now to average, I have to divide it by 2. So 64.84 divided by 2. 2 goes into 6 3 times. 3 times 2 is 6. 6 minus 6 is 0. Bring down my 4. 2 goes into 4 2 times. 2 times 2 is 4. 0. Bring down my 8. And then don't forget to put your decimal point up here. 2 goes into 8 4 times. So far, this is going great. 4 times 2 is 8. And then I've got my happy face Earth here. I got to get out of the way. 0. Bring down my 4. 2 goes into 4 twice. So our average time is going to be 32.42. I love it when I don't have remainders. It's really nice. Okay, so that is our average time. So let's 32.42. Remember that for me, because I'll forget it in a minute. 32.42. So basically the average number of days per Ozobot second corresponds to 32.42 actual days. We average it for a number of reasons. One, it's difficult for me to get this exactly right because the Ozobot's big, the arrow is small. It can be difficult for me to get it exactly right. And then it's just a way that we don't have to do 2 separate calculations. So each day, 32.42 seconds is actually a second in Ozobot time, or 1 second in Ozobot time is actually 32.42 days. It's pretty cool. Now the fun part. This is actually pretty cool to watch this. So we're going to look at these planets, and we're going to see how often they come in conjunction. So we are going to count, we're going to measure the time, and we're going to count 11 successive interior conjunctions of Venus as viewed from the planet Mars. So basically, we're going to be looking from Mars' perspective, and every time Venus hits it, that's 1, right? So what we're going to do is we are now going to, I'm going to reset my watch, and we have to count this 11 times. And then we're going to divide by 10, which I'll show you. All right, on your marks, and I'll keep if you want, I'll keep this up here, get set. Every time we see it from Mars, we're going to count and go. That was 1. Now remember, once it gets in with the Venus, we're going to count again. 2. 3. 4. Every time they go in a line, count 1 up. 5. 6. 7. 8. 9. 10. And one more coming up. Get ready to stop that watch. All right, 2:06. Cool. All right, they're gonna go over there, do their thing. So we have 2 minutes and 6 seconds. So how many times? 11 successive interior conjunctions. We started at 1, went to 11. 2 minutes and 6 seconds. So 60, 120, 120 plus 6 is 126. 126 seconds. Now what we have to do is we are going to divide by 10. Why do we divide by 10? Well, because it does 10 successful orbits, right? We're starting at 1, but we want it to go around 10 times. So it's actually dividing by 10 orbits. Just because it touches 11 times or gets in sync 11 times doesn't mean it's gone around 11 times. So now we're going to divide 126 by 10, which is 12.6. I'll double check with the calculator only because why not? By 10, and sure enough, 12.6. Now, what we're going to do is we are going to get our actual time and days. Right now, this is just telling us every 12.6 seconds, the Ozobots come into conjunction, right? Now, could you measure this just by doing it once? Yes, you could, but this gives you a better average, 12.6. Now, to get our actual time in days, we're almost done, which is cool. We're going to multiply our answer by our answer in step 10, right? So we're going to multiply 32.42 times 12.6. Remember, multiplication, don't have to have your decimal spots lined up. I don't really want to do this. I can. I'd rather just use the calculator and get through this. This isn't really a math lesson, although math is present in everything. 32.42 times 12.6 is going to give us about 408.49 days. So now, again, your answers may vary, right? You're probably going to get around 400, high 300s, 408.49 days. That means actual days. In real life, it actually takes Mars and Venus, every 408.49 days, they come into conjunction, which means they come into alignment, which is kind of cool, right? You figure the goddess of love and the god of war, right now they're apart. And now, there they go. And now they're together. And then they're apart again. Anyway. So, congratulations. This is like a complex problem in solar astronomy, right? Figuring out when the planets come into alignment. Or figuring out when eclipses happen. Or when the sun and the moon, right? All these things. You could actually use this, Ozobots, to solve these problems. Well, hell, that's it for me. What I'm going to do is I'll post a bonus video showing you like how we could use the bits. You could use the bits for these. It just doesn't look as cool because you only really have, if you look at here, if it gets into focus, right? You only have one light up there. Whereas if you have the bit, right? Sorry, the Evo only has a little light up there. The bit, like, it shows this whole light. So it actually looks like a planet, which is kind of cool. Now you can change that a little bit because there's a bunch of lights here on the Evo. I'll show you how we can adjust the program to do that. That'll be in a bonus video. But for now, hey, thanks for tuning in. If you have any questions, go ahead and leave a comment. If you like this video, fantastic. Just go ahead and click that like button. I'll probably put some more Ozobot videos up. I would like to do one of the whole solar system, right? Show you how to code that using the whole solar system. And once you have the code for Venus and Mars, it's super easy to just write the code for the different planets. The only thing you really need to know, if you want to set this up to kind of scale, is how far away the distances in AUs between the sun and the planets, and then just figure out a measurement, right? Figure out if you're going to do 0.72 AUs is 0.72 inches, or however you're going to do it. And the orbital speeds of the different planets. So what I'll do is I'll show you how to code those, and then we'll get like a whole big poster board and we'll make this happen. For now, it's Mr. Carey signing off. Hope you enjoyed the video, and I will see you next time.